Hi! I can prepare for my sketching polynomial functions and remainder theorem test by practicing. So I'm going to go through each type of question that's going to be on your exam, and it's up to you to practice each one of those. You know what's going to be on your exam, and it's just up to you, again, to practice and know how to do it. So, first things first, in your brain, you need to link together factors and zeros. So, if I'm giving you the zeros, then you know the factors. So, if -4 is a zero, then x plus 4 is a factor. If -2 is a zero, then x plus 2 is a factor. If +3 is a zero, then x minus 3 is a factor. To write the equation, we just put a p of x equals in front of it, and that's my equation. If they give you a graph, it's the same thing. We're just going to identify the zeros. In this case, the zeros are -2, 1, and 3. So p of x equals -2 gives me a factor of x plus 2. +1 gives me a factor of x minus 1. +3 gives me a factor of x minus 3. The only thing that we didn't talk about, if there's a zero of 0, the corresponding factor would just be x, because x plus 0 is x, and the opposite of 0 is 0. So you need to link in your brain factors and zeros. To go from one to the other, you're changing the sign. Zeros are just numbers. Factors have x's. This is going the opposite direction. Let's just go to a more complicated one. Let's try number 7. So a constant term in front does not affect the zeros. It will affect if it's opening up or down. It'll affect how high it's bouncing, but it will not affect the zeros. So if x minus 1 is a factor, then 1 is a 0. If x plus 2 is a factor, -2 is a 0. If x minus 3 is a factor, 3 is a 0. Now, because of these squares, these are going to be double roots. So I'm just going to kind of circle them and say double root. And now, just so you know what that graph's going to look like, I'm going to put my x-intercepts are 1, -2, +3. It's odd. We didn't really talk about this, but because there's 2 plus 1 plus 2, there's 5. It's going to be odd. Don't worry about that. This negative is telling me that it's negative, so it's going to be shaped like that. Now, because 1 and 3 are double roots, I know it's going to bounce off. So it's going to bounce off and bounce off. So that's what happens when it's a double root. It bounces off the x-axis, whereas a single root passes through the x-axis. And we're going to see that later in the review sheet as well. So if you have the factors, you have the zeros. If you have the zeros, you have the factors. If it ever asks you to find the remainder, you use remainder theorem. Remainder theorem is very simple. You're just substituting the opposite of what you're dividing by into the function. So from here, you can just put into your calculator. We also talked about an even easier way than using the parentheses. This is taking up a lot of space. So if I just pull up my calculator, I can do it with storing. -9, store as x. Again, you don't have to use the storing feature, but it's going to make things easier and faster. And then I just type in x to the 5th plus 3x to the 4th minus 4x to the third minus 2x squared plus x minus 3. P of negative 9 equals negative 36,624. Did I copy that down correctly? Yes. So that's the remainder. If I were to have used long division or synthetic division, I would have ended up with that same thing. A little follow-up question, which we're going to talk about later in this review sheet. Because it has a remainder that's not 0, I know that x plus 9 is not a factor of p of x. If the remainder was 0, then it is a factor, and again, we'll talk about that. In fact, I think that's probably the next question that we're going to talk about. And again, I'm just going to go through the odds. The evens are just additional practice for you, and you do have the key to refer to as you're practicing those as well. I'm sorry, before we get into the factors, we're going to talk about remainder theorem graphically. It's the same thing. If it wants the remainder, we do remainder theorem. So to do remainder theorem, I'm substituting the opposite of what I'm dividing by into the function. So if I'm dividing by x minus 1, I'm substituting 1 in. How do I do that graphically? Well, that's saying what's y when x is 1. When x is 1, y is negative 3. And that's it. So if you're doing the remainder, either way, you're substituting the opposite of what you're dividing by into the function. Algebraically, you're just replacing the x and you're finding the y by subbing in. Graphically, again, you're still replacing the x and you're finding the y. You're just finding that y value for that x value on the graph. To determine if something's a factor. Something's a factor if it goes in evenly. It goes in evenly if it has a remainder of 0. So your first step for determining if a binomial is a factor is to find the remainder. So I use remainder theorem, and I'm doing p of negative 4. So I'm substituting negative 4 in for x into all the x's. Again, I want to do it by storing because I can. X to the 4th minus 6x to the 3rd minus 4x squared plus 54x minus 45. And I got 315. So, since I got a remainder, it can't be a factor. So, I say, no, the remainder is not 0. I'm pretty sure for number 13, when you do p of negative 3, I'm not going to do the work right now, because I want you to do it on your own. But when you do p of negative 3, I'm pretty sure you get 0. Hopefully you do, or else I'm not making a very good video here. So if the remainder is 0, then you say, yes, the remainder is 0. So it's either no, it's not a factor because the remainder is not 0, or yes, it is a factor because the remainder is 0. To determine if a binomial is a factor, I need to find the remainder. To find the remainder, I use remainder theorem, which is substituting the opposite of what I'm dividing by into the function. All right, now, if it's multiple choice, it's the same thing. Which binomial is not a factor? So I'm going to go through each choice, and I'm going to see if it's a factor. To see if x minus 11 is a factor, I'm doing p of 11. To see if x plus 2 is a factor, I'm doing p of negative 2. To see if x plus 6 is a factor, I'm doing p of negative 6. To see if x plus 3 is a factor, I'm doing p of negative 3. So I have to plug in 11, negative 2, negative 6, and negative 3 into that function. This is where storing really is going to make things easier. So I'm going to start by storing 11 as x. And then I'm going to type in x cubed minus 6x squared minus 49x minus 66. I got 0. So, yes, that one is a factor. Now, choice 2, I'm going to sub in negative 2. Now, watch how easy this is. I'm going to do negative 2, store as x, and then I'm just going to copy and paste the expression which I already typed out. So to copy and paste it, I tab up so it's highlighted. I hit enter. P of negative 2 is 0. Since the remainder is 0, that means that x plus 2 is a factor. Now I'm going to try negative 6. So I'm doing negative 6, store as x, and then I tab up. I got negative 204. So since there's a remainder of negative 204, it does not divide evenly. That one is not a factor. But again, I always go through all 4 choices. That will help eliminate and catch mistakes. Negative 3, store as x. And again, I'm just tabbing up, copying and pasting. And I got 0. So since the remainder is 0, it's a factor because it goes in evenly. So choice 3B. Very common Regents question. The Regents always asks these questions to determine if it's a factor or not. I think it's an easy 2 points for us to get correct. All right, these questions are a little bit long. They're a little conceptual and computational, but you know, it is what it is. I'm going to go over 17 because 16's the algebra is a little bit nastier. Knowing me, I'm not going to give you an unnecessarily difficult, nasty algebra question on your test. So I'm just going to go over number 17, but again, you also have a whole video of me going over these finding K polynomial questions. So if x plus 3 is a factor, we talked about this earlier in the video, you need to link factors with zeros. So if x plus 3 is a factor, that means that negative 3 is a 0, which means that negative 3 comma 0 is a point on the graph. So if negative 3 comma 0 is a point on the graph, then I'm replacing p of x with 0, and I'm replacing x with negative 3. Now I'm doing algebra. Negative 3 cubed is negative 27. K times negative 3, is negative 3k minus 30. Combine like terms. Negative 3k minus 57. I do some algebra. K equals negative 19. So that's the first part of the problem. So I can replace the k in the equation with a negative 19. Now it wants me to find the zeros. So to find the zeros, I'll do this in a different color. Let's go Westbury green. I'm replacing p of x with 0. And now, to solve this, I want to factor it, but I can't. Since I know that x plus 3 is a factor, I can divide that x plus 3 out. To divide, I use synthetic division. So I list my coefficients. There's a missing x squared, so I put a 0 there. If you're not comfortable with synthetic division, then practice synthetic division. I put the opposite of what I'm dividing by outside. Bring the first number down. Then I multiply, add. Multiply, add. Multiply, add. So that's going to give me 0 equals x plus 3 times x squared minus 3x minus 10. I will always get a remainder of 0 when I'm doing this because I know that it's a factor. I know that it's going to divide evenly. Now I just do what I learned in the last unit. I factor it further. It's a trinomial. Once I know there's the factors, I know there's zeros. X equals negative 3. X equals 5. X equals negative 2. That's it. It's kind of a long procedure, but it's a procedure. If you follow it, if you practice it, you should be able to get it right in your exam. All right, just a little bit smaller. It wants me to sketch the graph of a polynomial whose factors are. So again, if I know the factors, then I know the zeros. So if x plus 1 is a factor, negative 1 is a 0. If x minus 4 is a factor, 4 is a 0. If x plus 2 is a factor, negative 2 is a 0. Negative 1, negative 2, positive 4. Does it say anything about double roots? No. It doesn't specify if it's positive or negative. It doesn't specify what the y-intercept is. So because they're not double roots, they're going to pass through. It doesn't matter if you open it up, if you open it down, how bouncy it is. Any polynomial graph that goes to those points will be sufficient for points. For number 19, I'm not going to do it, but for number 19, it's giving you the zeros. If it's giving you the zeros, you have the zeros already. You're not changing the sign of anything. You're not making it positive 5 because you already have the zeros. The zeros are where it hits the x-axis, so you don't have to change the sign of anything. If it gives you the factors, you change the sign to get the zeros. Which leaves us with one more type of question, which is kind of long. Shape. Let's see what we can fit on here. Let's go black. Shape. If it's even, it's U-shaped. If it's odd, it's chair-shaped. So since this is odd, it's got an exponent of 3. It's chair-shaped. It is positive. So the shape is chair-shaped positive. Y-intercept is the constant term, negative 27. Now the x-intercepts I'm giving to you, but you should know to find them, you're setting the equation equal to 0. And then when you do the algebra, when you do the grouping and you set each factor equal to 0, you get these x-intercepts. So there's a double root here, since that negative 3 is twice. So when I like to put that on the graph, I like to put a little circle on it. Positive 3 is a single root. Negative 27 is the y-intercept. Follow the shape. It's starting in the bottom left. It's going to bounce off the double root. It's going to pass through the single root. End behavior. What this is saying is, as the first thing, what that's saying is as the graph goes left, the graph is pointing down. That's negative infinity. As x approaches positive infinity, that's saying as it goes right, the graph is pointing up. That's positive infinity. Intervals. A lot of you are having trouble with intervals. I like to use colors for intervals to make things a little bit easier. You're looking at it from left to right. You're looking at it as a roller coaster. If you're going up the roller coaster, it's increasing. If you're going down, it's decreasing. It's going up. And then it's going down until it gets here. Then it goes up forever. Half the battle is recognizing it. The blues are increasing, the reds are decreasing. So it's increasing. The first blue piece is negative infinity to negative 3. And the second blue piece is 0. This x value is 0. And again, if you said 0.5, it's fine. It's approximate forever. Decreasing from negative 3 to, again, 0. That negative 27 should not be anywhere in your intervals. It's a y value. Intervals are always your x value. Positive, negative. I want you to block above and below the x-axis. I'm going to start with positive, so I'm just going to take my heart here and try and cover as much as I can. I'm going to do my positive in green. This piece is positive. Now, negative is everything below. I'm I'm going to do my below in purple. I know it might be a little confusing with the colors because there's so many colors, but I think we'll be okay. So green is positive, purple is negative. Let's start by writing the green. The only positive piece starts at 3 and goes forever. There are 2 negative pieces. The first one is negative infinity to negative 3. That's this piece right here. And then again, from negative 3 to 3. It's very common that students want to say it goes from negative 3 to 0. It doesn't stop being negative at 0. It's negative this whole piece. It may stop decreasing, but that's not what it's asking. It's negative, it's below, from negative 3 to 3. And that's it. That's your test. It's more practice problems. You know exactly what's going to be on it. Everything I just went over is going to be on it. Practice it. Make sure you know how to do everything. Ask questions if you have them. You have a lot of time from when I'm posting this video until you're actually taking the exam. So ask questions if you have them. And if you want to do well in this exam, you can do that by practicing everything that's on the review sheet. You also have keys for every type of question, full worksheets, videos. Use those resources. Use me. Use tutorial. And enjoy the rest of your day. Bye.